Hello viewers, hello students, welcome to our Tube Education. I am Belkis of your maths teacher. Today we will solve some question of exercise 13.2. But before solving question, I would suggest you to watch the introductory video of surface areas and volume. Link is given below in the description box. So first question is, a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius, that means 1 centimeter. Find the volume of the solid in terms of pi. So at first question number 1, they had told us a solid is in the shape of a cone like that and standing on a hemisphere, and given that this radius is equal to 1 centimeter, and also height of this cone, this is equal to 1 centimeter. So now we have to find the volume of this solid. So given that height of the conical part is equal to 1 centimeter and radius of the conical part is equal to 1 centimeter and radius of the hemispherical part also is equal to 1 centimeter. Now, volume of the solid. Volume of the solid is equal to volume of this conical part plus volume of this hemispherical part. Very easy question. Volume of conical part, volume of hemispherical part. Now volume of conical part, that means one third pi r square h. 1/3 pi r square h plus volume of hemispherical part, that means 2 upon 3 pi r cube. Now taking common 1 by 3 pi r square, that means h plus 2r. Now put the value 1 by 3 into, don't put the value of pi because they had told us find the volume of the solid in terms of pi. So this is pi into r means 1. 1 square, 1 plus 2 into 1. 1 by 3 into pi into 1 into 3. 3 cancel out, that means pi centimeter cube. So that's the answer, pi centimeter cube. Now next question number 2. Rachel, on an engineering student, was asked to make a model like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 centimeter and its length is 12 centimeter. If each cone has a height of 2 centimeter, find the volume of air contained in the model. So question number 2. They had told us an engineering student was asked to make a model shaped like a cylinder with two cones attached at its ends. Cylindrical shape and two cones like that. Two cones attach its ends. And given that the diameter of this model is 3 centimeter, this diameter is equal to 3 centimeter, and total length is equal to 12. This total length is equal to 12 centimeter. And also given that the height of the cone, each cone has a height of 2 centimeter. That means this height and this height, both 2 centimeter, 2 centimeter. So now you have to find the volume of air contained in the model. So volume of the air means volume of this conical part plus volume of this cylindrical part plus volume of this conical part. So it can be observed that height of the height, suppose this height is equal to h1, height of the conical part is equal to 2 centimeter, and height, suppose this is h2, height of the cylindrical part is equal to total length 12, 12 minus 2, that means 2 times of 2, that means 8 centimeter. And radius of this conical part, radius of the conical part is equal to 3 by 2 centimeter. Now volume of the air, volume of air contained in the model is equal to volume of the cylindrical part, volume of cylindrical part plus 2 into volume of conical part, 2 into volume of conical part, volume of cylindrical part, that means pi r square h2 plus 2 into 1 by third pi r square h1, taking common pi r square, so h2 plus 2 by 3 h1. Now put the value. Pi means 22 upon 7, r means 3 by 2 into 3 by 2, h2 means 8 plus 2 by 3 into 2. So that means 11 by 7 into 3 into 3 upon 2 into 3, 3 8s are 24, 24 plus 4, 28. 3 3 cancel out, 7 4s are 28, 2 2s are 4. That means 33 into 2, 66 centimeter square. That's the required answer. So now next question, question number 3. A gulab jamun contains sugar syrup up to about 30% of its volume. That means Whatever its volume, a gulab jamun contains sugar syrup up to 30% of its volume. Find approximately how many syrup would be found in 45 gulab jamuns. And given condition is each shaped like a cylinder with two hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. So at first clear the concept very well. Here given that question number 3. A gulab jamun like cylindrical shape, and this is two hemisphere with length 5 centimeter and diameter 2.8 centimeter. This diameter 2.8 centimeter and this total length 5 centimeter. So now given that given that radius of the hemispherical part is equal to total diameter 2.8, that means 2.8 by 2, 1.4 centimeter. So that means also height is equal to 1.4 centimeter because radius is equal to height. So that means this is also 1.4 centimeter. And height of this cylindrical part and height of the cylindrical part is equal to total length pipe minus 2 times of 1.4 and 1.4. Total length 5 minus 1.4 minus 1.4. This is the length of this cylindrical part 1.4. That means 5 minus 2.8. That means 2.2 centimeter. So this is the height of cylindrical part. Now volume of one gulab jamun. Volume of one gulab jamun is equal to volume of cylindrical part plus 2 into volume of hemispherical part. So total volume is equal to volume of cylindrical part plus volume of these two hemispherical part. That means volume of cylindrical part, that means pi r square h plus 2 into hemispherical part, that means pi 2 by 3 pi r cube. Now taking common pi r square. This is h plus 4 by 3 r. Pi r square into h plus 4 by 3 r. So now put the value. Pi means 22 upon 7. R means 1.4 into 1.4. H means 2.2 plus 4 by 3 into 1.4. So 7.2. 22 into 0.2 into 1.4. That means 22 into 0.28 into 22 2.2 plus 4 by 3 into 1.4, that means 1.86. Now 22 into 0.28 into 2.2 plus 1.86, that means 4.06. Now 2.2 into 0.28 into 4.06, that means 25 centimeter cube. So this is the volume of one gulab jamun. Now volume of 4 gulab jamuns, 45 gulab jamuns. Now volume of 45 gulab jamuns is equal to 45 into 25. 45 into 25, that means 1125. 1125 centimeter cube. Now you have to find the volume of the sugar syrup. Volume of the sugar syrup is equal to 30% of its volume. 30% of its volume. That means 30 by 100 into 1125. 1125 00 cancel out. So that means 3375 by 10, that is 337.5, approximately 338 centimeter cube. So that's the answer. Now next question, question number 4. A pen stand made of a wood is in the shape of a cuboid. Suppose question number 4. A pen stand made of a wood is in the shape of cuboid. Like that. And with 4 conical depression to hold pens. For holding pens, 4 conical depression. Suppose this is 4 cones. And the dimension of the cuboid, that means length, breadth and height, is equal to 15 centimeter by 10 centimeter by 3.5 centimeter. That means this is 15 centimeter, 10 centimeter and this is 3.5 centimeter. And also given that the radius of the each of the depression is 0.05. Radius of this is equal to 0.5 centimeter and depth is 1.4. That means height is 1.4 centimeter. Now find the volume of the wood in the entire stand. So for that you have to just remove the volume of these 4 cones. So that means given that height, breadth and at first length, L-E-N-G-T-H, length, breadth and height of cuboid is equal to 15 centimeter. Cuboid are 15 centimeter, 10 centimeter and 3.5 centimeter respectively. And given that radius of the conical part is equal to 0.5 centimeter, that means half centimeter, and height of the conical part is equal to 1.4 centimeter. So now volume of the wood. Volume of the wood is equal to volume of the cuboid minus 4 into volume of this cones. So that means volume of cuboid minus 4 into volume of cones. Now volume of cuboid means L into B into H, L into B into H minus 4 into volume of cones, that means 1/3 pi r square H. 1/3 pi r square H. Now just put the value. L means 15, 10 into 3.5 minus length 15 and breadth 10 and height 3.5 minus 4 by 3, 22 by 7. R means half into half. 0.5, that means half, into H is equal to 1.4. 0.2, 11, 2. Now 15 into 10 into 3.5, that means 5 to 5, minus 2 into 11 into 0.2 upon 3. That means 1.47 is equal to 523.523.53 centimeter cube. 523.53 centimeter cube. That's the answer. Thank you.